Let's talk about the BroodMinder T2 and TH2 internal hive sensors. They measure temperature and temperature humidity and are designed to go right inside the hive on top of the brood nest. They're going to tell you more about colony health than any other sensor, especially for the price. In my mind, the temperature is by far the most indicative parameter that we measure, and this one will tell you a couple of things. One is we all know that when the brood is being raised, the bees are going to regulate the hive temperature to 95 degrees Fahrenheit, 35 C, and as the brood strength goes up, they really control it closely, so within a degree. So by looking at the internal and external temperatures, we can make an estimate on the brood strength. It's also going to tell you the queen status, because if she's not in there doing her job, they quit thermoregulating and you'll see it follow the outside temperature. Another cool thing that we didn't realize when we started is that it shows swarming really clearly. When a hive swarms, you'll see the temperature go up about 6 degrees Fahrenheit, 3 degrees or so centigrade, and that lasts about 20 minutes. So the sensors are looking at the temperature once a minute to see if we see that profile or not, and if we do, then it stores the 30 minutes before and the 30 minutes after. If it doesn't, it will store once an hour, which is plenty of granularity for almost everything you do. A couple other features, we made it so that the battery lasts over a year, typically about 2 years. If you have a hub and set it up right, then you can get 5-year battery life. The case is like this. The action part is down here. This is to encourage it to the center of the hive, and then you'll also see that the ID number is both on this and on the circuit board. The cases are replaceable. They're slippery, and bees tend to not propolize slippery things too much, but they will, they will get goobered up, and you can replace them. We sell replacements, or you can send them in for refurbing. The data is stored on the device for about a year. A year's worth of data fits okay. So you can go and read it with your phone every week or two, or every day if you want. Or you can have a hub. The cell hub we highly recommend when you have a lot of these, to read it once an hour. Or if you do get a swarm alert, then it'll send that within 10 minutes. So that's the main features of it. Strongly encourage that this is the most important sensor we sell. Of course, if you're into honey, then you'll be sure and want to look at the weight scales. Okay, so let's talk about installing a T2 into your hive, or a TH2. They're practically the same. You might want to do this at home the first time, just because at the dinner table it's easier to figure it out and everything. Once you understand how it works, it's very easy to do in the apiary, to move devices, to reassign them, and those sorts of things. So we'll do that. You want to start up the Bees app, and you'll want to establish a My BroodMinder account, and you'll want to create an apiary and a hive. That'll come in handy later, and it just is good to get that out of the way. You can see that in other videos. So once you have all of that, you want to take your T2 and pull the battery tab. Once you pull the battery tab, you will see it flash here for about 20 seconds, and then you'll also see it show up in the Bees app. So that flashing lets you know that it's running and everything's working okay. And after about 20 seconds, it'll stop. It'll never flash again, because we don't want to use the power up from the battery. Okay, so it showed up here in devices, and if it has already been claimed by somebody, if you got this from someone else, you won't see this claimed device, and you'll need to reach out to Mike to have that disconnected from the old account. But we'll push claim device. Claiming device adds it to your My BroodMinder account. If you wish to claim it, yes, I do. You don't want to claim other people's devices, because then they won't get it. Okay, and we want to assign it to a hive right now. So I have an apiary called Bees on Main. I have a hive called Hive 01, and the location I'm going to put it inside the hive is I'm going to put it above the lower brood nest. Okay, and we say done. You can adjust the start and stop time if you know you're going to do it tomorrow or whatever. And we hit save. So now the device is moved, it's there, and it shows in this, it's located in Bees on Main, Hive 01, lower brood. So that's all nice. Now when you go to the apiary, let's see here, let's go over here. Now when you go to the apiary, you'll want to install it. You might assign them all before you go, and then put it in. And it's really just as simple as putting it, you want this part, which has the sensor in it, to be roughly in the middle of the hive and over the brood nest, if that's if you're looking at the brood temperature. And you know, the length helps you do that. Just put it in. This can be sticking out. It can be left in if you don't like it sticking out. It's just for convenience in case you have a lot of them to be able to see what the ID is. And now it's active. We can go in there. We can look at show details, and it will show you that. I think we can change the rate. We can sync it. So when you go out to the apiary, what you'll do is you'll sync your devices, and that'll pull the stored data off the devices. So that's really pretty much it. We'll get into utilization and everything, but right now it's installed and it's operational. Okay, something else that's a little bit tricky, so you want to probably look at the manual on this also. But if you want to enable battery saver, that can make the batteries last in these devices over 5 years. You only want to do that if you have a hub, and what it does is that instead of broadcasting its data all the time, so if you walk up with your phone you can see it, it only does it for 10 minutes per hour. A hub will catch that because it's looking every 10 minutes, and so we save the power that way. What it means is, though, if you walk up and battery saver is enabled, it may take you a while to connect to the device. So if you have a hub, this is great. And the way you do it, you go to settings and you go to enable/disable battery saver. Okay, so if we do that, and you want to then, it goes out and looks for ones in your account that you can do this to. So it found the one we just installed. You can go to setup, and it also doesn't need to be looking for swarms all the time. So here in Wisconsin, we really don't need to look for swarms until March. And you know, I don't care about swarms after August. Whoops. Let's go back there again. Get August and say done. Yeah, so we have a hub. We want to schedule swarm detection, and it'll do it from 5 a.m. to 8 p.m. During the day, and it's only going to do it from March 1st to August 1st. Then down below, it sort of tells you how many years the battery should last then. So the T2 should last about 4.5 years. If we squeezed it down more, we could get more out of it. I thought we could also, oh yeah, we can change the time. Maybe we don't need to go till 8 p.m. Because my swarms don't happen then. And if we go from 5 to 4, then it lasts 5 years. So you can adjust all this and then say done. And then if you say enable, right now this X over here means that it's not enabled. We say enable, and it will connect to it, adjust the sensor, and you can see now it has a check mark beside it, and it's both saving battery life and is also only doing swarm detection during part of the year. If you want to take it out of that, then you'll hit disable, and it may take 10 minutes to do it. So it'll tell you the status down here below, but if you caught it at a bad time when it's not advertising, it'll have to wait till the phone can find it. So anyway, It's a little bit confusing. It's really great if you're technically savvy, then it's a good way to save power. If you're comfortable changing the battery, every fall, then you can do that. But if you have a lot of devices, it can be nice. The other thing I'll show you is if you do want to do a firmware update. We haven't needed to do a firmware update for several years now on these devices. Then you have to turn it on. Then it will tell you which devices need a firmware update. It'll put a little exclamation mark, and you can do that. And that's a pretty simple process. Also, it'll show up, well, in fact, here, firmware update available. So let's just do it. So let's do this. And I can either lose the readings or save them. I don't care, so I will let them be lost. Otherwise, it would do a sync, then do the firmware update. So you can see it's telling us it's connected. And now firmware update progress here at the top, 4%, 6%. Goes fairly quickly, but if you have a lot, it can take a while. And this is doing it over the air. If you need to do a firmware update for some reason, we can let you know. Otherwise, you don't really need to worry about it. Our devices that have the firmware that we initially sent 8 years ago, it still works. So we make sure that we don't obsolete things out there. So we're up to 55%. We'll take a pause for a few seconds. Okay, completed successfully. Disconnected. The little exclamation mark went away. You can hide that information if you want by touching it. And it's telling you that when the last sync was, battery saver enabled. So when we did the firmware update, it disabled the battery saver. So let's go back to that. Enable. Nothing in progress. Should find it here in a few seconds. There it is. So now we'll re-enable it because a firmware update just starts everything from scratch. So you need to do that. Also, if you replace the battery, we always start from the same place for reliability's sake. You would need to re-enable it then. So it's connecting and applying settings. Finished. We got green. And there we go. And now if we look at it, we can see battery saver enabled true, activity scheduling enabled true. You can double click on here, see the graph. We haven't taken much data, so it's pretty small, but it also gives a lot of status down here. The last thing I'll show you is how to change the battery. We've gone through several different designs of the case. As time goes on, we learn little tweaks to it. The old ones work, but the new ones we think are a little bit easier to install out in the field. So if you're doing it in the field, it can be pretty klutzy. There again, we recommend almost, pull them all, put them in a box, take them inside, do them, then redeploy them. Alternatively, we do have a refresh service. You can throw them all in a box, send them back. Donna will clean them, test them, make sure that everything's working right, put in new batteries and housings, and send them back. So if you got a bunch, that's really a pretty good way to do it. We do put a piece of tape around it just to hold it together better. So if you're going to change the battery, you're going to want to slit that tape. So let's just do that. See if I can do it in a way that it shows. The tape is very hard to see. Okay, so once that tape is slit, well, this one's still got the battery tab in it, so we'll take that out. Then this just unfolds like that. And then you can slide the board out. We'll go ahead and take this battery out. Even though it's brand new, we'll put the battery back in. In fact, I'll put it back like we do in production. Well, we won't do that. Just put the battery in. When you put the battery in, you'll see that the light flashes again because it just started. All the data was lost, so you need to synchronize it before you do a battery change. But it just starts up like it's new again. Then you close it, and let's show you how to fold this. So when we ship these, they're shaped like this, and what I generally do is pre-fold these sides. There's two little ones, and you do this a few hundred times and it gets easy. Okay, and then these two tabs lock together like that. It forms a little groove that the board goes into. That space is where the battery goes. Then you can fold this guy up, fold this around, and it goes through the first tab, and then it goes back through the second slot. I guess they're not tabs. Okay, so let's show that again. So the two flaps fold together. This goes in with the battery in this slot, in that hole. Okay, then you're going to fold this end up, fold these two creases right there, goes into that slot and into the second slot, and you're done. Then we think it's a good idea to take a piece of packing tape, and just put around here. Packing tape's a little bit better than normal Scotch tape. You don't have to, it'll be fine like this, but as you're yanking it off with the propolis and all, it holds together a little bit better. So that's how you change the battery, change the case. And I think that's all of the maintenance things. Things that go wrong. Some of the older devices had buttons on them because we hermetically sealed the case and we started it with a button. Those buttons were a reliability problem, so we've eliminated them. If you have a button on it, update the firmware and cut that button off. It just is nothing but trouble. If you get it in a extra tight hive where the button's pushed, it can create issues with that. So the buttons can go away with the new firmware. The other thing that happens is, if it's open and they propolize it, it can make the circuit board a mess. We are really sipping the power out of this battery, and if it gets propolized, then it can drain the battery quicker than it should. So if that happens, send it back for a refresh. If it doesn't work, then Donna will offer you up a refurb device, which is basically half price. So you can take that if you want. And that's about the extent of everything I can say about T2 TH2 maintenance. For anyone interested out there, I'll go through a little bit of the history. You do not need to know this information, but I know some people are interested in this. I would be if I were out there. So I'll just tell you a little bit of the history over the last 10 years, I guess it's been now, since we began. These are the various phases we went through. Back from the prototype, very early days, figured out after having a matchbox eaten by the bees that packing tape worked really good, so that made a whole series of them. Found out that using a slippery tape, slippery plastic, they really didn't bother it as much as the bees really like to propolize rough things. We went through a couple of different iterations of what it should look like. The first ones we shipped looked like this, which were sort of pretty and had some beehive things on it. But then when we redesigned it and included the scale, Nick, who was doing our industrial design then, we went for the more clean look across all our products. So we went through this one. We had this model which folded across like that and worked really nicely, looked pretty cool. Its flaw was that these tabs broke off originally. Some of the people remember that, so we changed the number of holes, some simple things. Started putting tape here because some people would leave it sticking out of the hive a little bit, and rain, if it rained against the side, would wick in and get to the circuit board. So because of some of those problems, we thought, okay, well, let's just hermetically seal it. Let's take it, and actually the label and the tape, and this is vacuum formed, and it worked really good for the T2s, the temperature only devices. A little bit tougher because for the humidity devices, you couldn't get to the humidity sensor. So that made us evolve into this style, and we've been through actually a couple of versions of this, tweaking small amounts of it. But where it was folded up better, we had some complaints actually at EAS, where these were sort of good in a lot of ways, but as soon as it got any propolis or any wax on it, these were really hard to seal up a second time. So we went back to where they fold together and go like that, put a little piece of tape around it, like that. As far as the circuit boards go, and this was our first one that we did for our crowdfunding back 10 years ago. And we found out quickly that as soon as we shipped the first 500 units, Texas Instruments told us, oh, by the way, the temperature humidity chip you use, the humidity will go bad in about a year. It'll just keep going up until it it only reads 100%. That was pretty devastating for us because there was no solution other than to redesign it, use Sensorion then instead of Texas Instruments. And that's when we changed, and we also added on the circuitry for the scales to read the scales, trying to do all that and make mass production. So we try to keep uniform across all these different things. The problem with these also was the battery holder and the normal thickness board made it, just a little bit over 1/4 inch. And beehives among manufacturers, they vary a little bit on the dimensions, and if you mix and match beehives, then you end up with less than 3/8 of an inch, which you're supposed to have. But some of them, had trouble fitting. So then we changed to a thin circuit board, a half thickness, and also to this type of battery holder, which the overall profile, is only about a millimeter, maybe 2 half, well, probably about a millimeter thinner, but that can make a big difference inside a beehive. So from there on out, we've always used thin circuit boards, the 2032 with the battery holder like this. Originally, we were using Blue Giga BLE112 Bluetooth devices, which were really nice and very quick to implement. Blue Giga ultimately got bought by Silicon Labs, and they sort of phased out that product. It used a script called BG Script, which made it very quick and easy to develop the firmware that's stuck in here. And we did that and everything. But then when they were phasing out that, we changed to the new Silicon Labs chip, and it was all C-based. So we had to change our development environment. It was a lot more complicated of an environment, but it also gave us a lot more features. So that's when we introduced the T2, which was basically doing the same thing as this, but instead it was measuring once per minute. And with once per minute, we could watch for the profile of a swarm during that. And if that happened, then we could save the data differently. So the firmware got quite a bit more complicated to do this multiple rate thing automatically, but it has been, a really good change. Rich Hogel has done a terrific job at the firmware for that. So all these still work, and they talk the Bluetooth language, which is in our manual, the advertising language, and then we have a lot of commands that we can send to it. But the rectangular boards, we had to redesign the case again, and like I said, we went with the hermetically sealed one originally. That forced us to put a button on it to start it, and buttons are less reliable than you would think. So, that gave us problems over the years, and we finally just decided, hey, we don't need the button. We'll use a battery strip. We won't hermetically seal it, but we'll make it rugged, and we'll conformally coat the circuit board so that they resist that. The propolis and the high humidity interacts with the solder flux and can create these little tendrils which make the battery go away, and those sorts of events happening which are undesirable. So right now it's pretty stable. We're very happy with it. It's very simple. It's got the Bluetooth chip and a temperature and/or temperature humidity chip here. That makes it so that we can make it as cheaply as we can. It's this size because the antenna is built into the board, and for the maximum Bluetooth range, it needed to be this big, and with the battery. So all these different things trade off, and we just work to optimize those. You can see it took us several years to, work through the various little problems and opportunities we have. But now it all is pretty stable. The advertising, the connection, the changes we made most recently were to watch the energy consumption of the battery. Just we calculate it as time goes on. And then also to be able to turn on and off the advertising, the amount of advertising that goes on to extend the battery life, and how many hours a day it's looking for swarms. And by doing that, we've gotten to where we can have a 5-year battery life. We spent a lot of time on the optimization of the power, and all these things trade off. How often you advertise? These advertise once every 5 seconds. If it does longer than that, phones have trouble reading it and seeing it. If you do it more than that, your battery consumption, energy consumption goes way up. So that's a little bit of the history of it. We also ran into problems when we changed here. Static would reset the devices. So that was, we spent several weeks really trying to figure out how to set the microprocessor to be resistant to that. We had to turn off some external, and you run into all these problems along the way that you don't expect. Converting from one language to another, that was a big deal. And now the new devices are actually using a different system. So, as time goes on and we evolve to it, that'll mean rewriting the firmware yet again. But what we try to do is hide that to the user so that, our phones and hubs and devices, they will still work with the oldest devices we've made. I still have them in my apiary, and that's part of the game that we played. So that's a little bit of the history of the BroodMinder T and T2 and TH and TH2. I hope you've enjoyed this. I hope it's useful. And remember, every hive counts.